When it comes to searching for alien life, we're left with just two simple possibilities. It's either we are alone in this universe or we're not. But however the case may be, both are equally terrifying. Let me explain why. Firstly, the thought of being alone in this universe is quite unsettling. It would mean that Earth, with its vast diversity of life forms, is the only place where intelligent beings exist. The implications of this are profound. It would imply that the emergence of intelligent life is an exceedingly rare event, perhaps even a miraculous occurrence. It would also mean that the fate of the entire universe rests solely on our shoulders, as there would be no other civilizations to share in the exploration and understanding of the cosmos. On the other hand, the possibility of not being alone in the universe is equally terrifying, albeit for different reasons. If there are other intelligent civilizations out there, it raises the question of their intentions and capabilities. Are they benevolent, or do they pose a threat? Are they more advanced than us, or are we the more advanced species? And where exactly can we find them? I'm sure many of you here must have heard of the Fermi Paradox. But if you've not heard of it, let me break it down for you. It goes like this. What do you feel when you look up at the sky on a clear night and see an infinite number of stars shining like the brightest diamonds? Despite being breathtaking, this view is just of our closest neighborhood. Far beyond the reach of our best optical systems lie thousands of other galaxies, stars, and planets. There are as many galaxies in the universe as stars in our own Milky Way galaxy. You might be wondering where I'm going with all this. But let me finish. With all the greatness of planets, stars, and galaxies out there, where exactly is everybody? Or put another way, where are all the aliens? Are we really alone in the universe? Shouldn't there be other intelligent civilizations out there? The questions and answers that arise from all of this are called the Fermi Paradox. Here we are floating around on our little blue planet, thinking we're all that. We've got our advanced technology, sending out signals, launching probes, and dreaming of boldly going where no one has gone before. But guess what? We've found nothing outside our planet. When we hear about the Fermi Paradox, we always acknowledge Enrico Fermi as the one who started the argument because of his famous launch conversation, where he asked the question. But however, the Fermi Paradox was not initially posed by Enrico Fermi himself. The concept had been implicitly mentioned earlier by Konstantin Tsiolkovsky in an unpublished manuscript from 1933. Tsiolkovsky observed that some people denied the existence of intelligent beings on other planets in the universe. Their reasoning was based on two assumptions. If these beings existed, they would have visited Earth, and if advanced civilizations existed, they would have provided some evidence of their existence. While this lack of evidence was not seen as a paradox by many, it posed a paradox for Tsiolkovsky himself. He firmly believed in the existence of extraterrestrial life and the possibility of space travel. To reconcile this, Tsiolkovsky initially proposed what is now known as the zoo hypothesis. He speculated that higher beings, aware of mankind's unpreparedness, have chosen not to make contact with us at present. According to Tsiolkovsky, humanity needs to reach a certain level of advancement before being deemed ready for contact. Over the years, we've discovered more than 5,000 planets, and some of the planets we've discovered reside in the habitable zone of their parent star. But this is just a small number compared to the vastness of the cosmos. It's like trying to count the grains of sand on all the beaches of Earth with a single teaspoon. We're talking about an astronomical number of planets, each with its own unique features, potential for life, and cosmic real estate value. And let's not forget, the habitable zone is just one piece of the puzzle. There are countless other factors that could contribute to the existence of life on a planet. From atmospheric conditions to the presence of liquid water, the cosmic recipe for life is a complex one. In our Milky Way galaxy alone, according to experts, we have about 100 billion to 400 billion stars in our galaxy alone. This number might also be the same as the number of galaxies we have in the observable universe. That's a lot, right? I'm just getting started. Among all the stars in our galaxy, an interval between 5% to roughly 20% are like our own star, the Sun. meaning they have similar size, temperature, and luminosity as our own sun. If we are conservative and take the smallest quantities from both intervals, which is 100 billion stars, out of which 5% are sun-like, we arrive at the approximate number of sun-like stars in our galaxy, which is 5 billion stars. With all of that, let's now consider what percentage of these stars could be orbited by planets with similar conditions to the one we live in. A temperature similar to ours and the possibility to hold liquid water and potentially develop organic life. Some scientists say this number could go up to 50%, and for some, it's roughly 22%. Let's go with the smaller percentage. It then gives us about 1.1 billion sun-like stars that could be orbited by planets similar to planet Earth just within our galaxy. And then, from this point, there's not much science that needs to be done. All we can do is speculate, but let's continue. Okay, let's say out of these 1% develop life, and from that 1%, another 1% develop an intelligence similar to ours. This would result in more than 100,000 intelligent civilizations in our galaxy. Taking into account the efforts made by US humans in the last century to try to contact extraterrestrial life or gather information from other intelligent civilizations, and the number of possible civilizations that probabilistic ally should be out there, shouldn't we be receiving signals? Why have we never received any kind of information or contacted other intelligent species? The universe as we know it is 13.8 billion years old now, right? And our star, the Earth, and possibly every structure in our solar system are roughly 4 to 5 billion years old. With this in mind, think for one moment about the differences between civilizations on planet Earth 500 years ago and our current civilization now. If we are so different from them in just half a thousand years, imagine how much more evolved an intelligent civilization that is 10 or 100 times our age would be. We might even be like monkeys to them, probably. Their technology and science would be completely incomprehensible. When we take a look at the Kardashev scale, it helps us differentiate civilizations depending on their technological and scientific capacities. It all began back in 1964, when the Soviet scientist Nikola Kardashev introduced a classification system that categorizes civilizations based on their technological advancement and energy utilization. This system, known as the Kardashev scale, encompasses various levels, starting from Type 1, denoting a civilization that has yet to fully harness the potential of its own planet, to Type 3, capable of harnessing the energy of an entire galaxy. So, basically, a Type 1 civilization should or would be able to control the energy of their planet, every single energy the planet has to offer, from earthquakes to different weather conditions, and then a Type 2 civilization should be able to control the energy of their entire parent star, which would require building some kind of Dyson sphere around the star. And a Type 3 would control all the stars in their galaxy. They'll be able to travel very fast, maybe as fast or even faster than the speed of light. So, where do we find ourselves on this scale? We occupy the position between 0 and 1, and it's going to take more than a century to reach a Type 1 civilization if we'll be able to maintain our race till then. Yeah, that's basically what the Kardashev scale is. But however, the scale goes up to Type 7 civilization. You can click the video in the description to watch it. But don't go anywhere yet, because we are not done. Carrying on with our previous speculation, let's imagine that 1% of intelligent life survived long enough to become a Type 3 civilization. That would mean there should be at least 1,000 Type 3 civilizations just in our galaxy alone. Also, civilizations of this sort wouldn't be too hard to detect. So, if I may ask, where is everybody? And now, what are the possible solutions to this paradox? One argues no super-intelligent beings exist, while the other suggests less concrete reasons for the lack of contact. The first is the theory of the Great Filter. This solution suggests that from the very beginning of life's emergence through the intricate stages of development, all the way up to achieving highly advanced civilizations on the Kardashev scale, there exists a significant obstacle that hinders the progress of life, making the existence of detectable extraterrestrial life extremely rare. The idea was first proposed in an online essay titled "The Great Filter, Are We Almost Past It?" written by economist Robin Hanson. With no evidence of intelligent